Hi, my name is Remy Pangle. I'm with the Center for the Advancement of Sustainable Energy here at JMU, and today I'll be giving you a tour of our wind facility here on campus. So this facility was built in 2012, and it's actually a hybrid facility. That means that it also does house a small solar array, so we are getting power from both the wind and the sun. That power is being stored in batteries inside this building, and then conditioned to be utilized to power this facility, the lights, the computers, the monitoring systems and such. If we are using more power than we're producing, we can pull energy from the JMU grid, and conversely, if we're producing more power than we need, we can also push it out to the JMU grid. So this facility is a great demonstration project to show how wind and solar can be used to power something like a home in an off-grid or an on-grid situation. Okay, here we are at the solar array in our wind facility. We have 15 solar modules or solar panels, each of them rated at 50 watts, and those solar modules make up our solar array for a total of 750 watts of total power. That's at certain optimal conditions. And those conditions would be a cloudless sky in the middle of the summer at solar noon, which it isn't today. So today, we might be getting on the order of 400 or 500 watts of solar power. And when we go inside the building, I can show you how much solar we are producing. But our solar panels, as you may notice, are on a fixed axis. So they are not tracking and they don't move, but that means that they have to be at a very particular angle and orientation in order to get the maximum solar power. So these solar panels are facing south because the sun is always over the equator. When we face our panels south here in Virginia, we're gonna see the sun all day when it rises in the east and sets in the west. The solar panels are also at a very particular angle, and that angle here in Virginia is 38 degrees or so. It's basically the same as our degrees north of the equator or our latitude. So this is how we can get the most out of solar panels that are fixed. Okay, so here we are at the wind turbine here at the wind facility. Our wind turbine over here is on a 120-foot tower. At the top of the tower is a Berge XLR wind turbine. Each of those blades is about 10 feet long, and it has a tail on the back. And so this is a very simple turbine. It's great, it's robust. We have never had any problems with it, knock on wood, since we installed this in 2012. It is a direct drive system, meaning that there is no gear system. So the blades simply turn the shaft of the generator inside, and then that generator produces electricity. Like I said, the electricity goes into this building, conditioned and stored in batteries, and then can be used to power the facility. This turbine is rated at 7,500 watts. So again, that's at optimal conditions. So on a day like today, it might feel like it's windy, but we're probably not windy enough to be maxing out that generator right now. I believe that the turbine maxes out at somewhere at 18 meters per second, which is somewhere in the 20-something, maybe 28 miles per hour. So it has to be pretty gusty in order to be getting all 7,500 of those watts of power. Now it cuts in at about 3 meters per second or 8 miles an hour. When we go inside the building, I can show you about how much power it is producing. You may also notice when you look at the tower that there are lots and lots of instrumentation on the tower. And you'll see lots of both of these. This is called an anemometer, and it measures wind speed. This guy over here, which just looks like a tail, is called a wind vane, and it's gonna tell us the direction that the wind is coming from. Both of which are very important to tell us about our environment here and to tell us about how efficient our turbine is taking that kinetic energy in the wind and turning it into electrical energy that we can use. We measure that in a lot of different places because we want to know how the wind is performing in different locations, but also at different heights because the wind speed does increase with height. You'll notice we have 3 levels of anemometers and wind vanes on the tower. And then on each level, we have 2 anemometers and 2 wind vanes at different angles, because depending on the direction in which the wind is coming, the tower could actually shade the instrumentation and throw off any of our data. So we like to have redundancy so that we can verify wind speeds when the direction changes. All of that is done for a lot of the research that we do here with university students. We also have a WeatherBug system. So if you have the WeatherBug app, you can log in, and if you look and find the JMU location, you're going to be seeing the weather right here at our wind facility. It has an anemometer and a wind vane, but it also has a rain gauge and a temperature gauge and a barometer and hydrometer, all the things. So you'll get a full weather forecast from right here on our wind facility. I get the question a lot, and I will just say, no, we're not allowed to climb this tower. We actually have to contract somebody to climb up the tower, but there is a person who does climb it once a year and just make sure that the turbine is performing at its peak and optimal state. So we are excited to have the turbine here. This is a great demonstration. This turbine is probably bigger than any single home would need in terms of how much power it generates, but is super appropriate for a farm. And we love having it with the solar panels because the solar and the wind complement each other in this hybrid system. On a day like today, we have a beautiful cloudless sky and we have wind, so we are just having the best day over here at the wind facility today. Okay, here we are inside the building here at the wind facility. So like I said, in this building is where we have all the equipment that we use to condition the power so that it can be stored in batteries and then used to power the building. The building itself was built to be energy efficient. Hard to tell from a video, but these are south-facing windows which allow us to get heat in the winter to reduce how much heat we need from our air conditioning and heating unit. The unit that we do use for HVAC is a high-efficient mini-split system. We have LED lights on the ceiling, so we have done our best to make this small building as energy efficient as possible so that we can make the most of the power that we're generating here. So like I said, we have both wind and solar power that we are generating. So the wind power comes in over here, and our solar power comes in over here. Both of them are in DC power, which means that it is in direct current, and direct current power is what we can store in the batteries. So there's not a ton of conditioning that needs to be done, just a voltage matching in order for that power to be stored in the batteries. We have 16 lead acid deep cycle batteries over here that store our power. It's about a 48 volt system. And rule of thumb is that we should have enough battery storage to be off-grid for up to 3 days. It remains pretty well charged with the small solar array and the wind turbine that we have. When we need power here in the building, if we flip the switch and turn on the lights, or if the air conditioning is running, we have the computers and the monitoring systems. That power is pulled from the batteries, but as DC power, it cannot be used to power an AC outlet or AC appliances. So it has to come through first the inverters. So these are the inverters, and these inverters are going to take that DC power and turn it into AC power so that we can utilize it. Now, this system is also at 48 volts, but in our homes, we use 110 volt power. And in order to match that, the energy then needs to come from the inverters to a transformer. And then the transformer is going to step up the voltage. So now we have AC power at 110 volts, and we can use that to power the building. So the question is, how much power are we producing today? So we were outside and you saw how windy it was. So looking at the anemometers and the data from the anemometers, we find that at the highest anemometer, we're gusting at about 12 meters per second. It's pretty good. It sounds pretty good, but when we look at the wind turbine's power curve, that tells us that at 12 meters per second, we're generating 1,000 watts of wind power. And again, I told you that that 7,500 watts of power that we can get out of that turbine happens at about 18 meters per second, or 28 miles an hour. So we're definitely not there today, but we're getting about 1,000 watts. When it comes to the solar, like I said, we have 750 possible watts of solar. Those are over 20-year-old solar panels, number one. And we are in the end of October, which is not optimal in terms of the time of year to get the best sun. We have a pretty cloudless day, which is good. And for us, it's about 2 o'clock in the afternoon, so not too far off of solar noon. But still, under those conditions, we are seeing only 460 watts of solar power out of that 750 today. But together, we're almost at 1,500 watts. So the question is, are we pulling electricity from JMU's grid, or are we giving it to JMU's grid? Assuming these batteries are full, we are not using 1,500 watts at the very moment. We have the air conditioning unit, which is going to use some, but we don't have the lights on because we're using our natural passive solar. And the computer is off for the most part. So I would say that today is a good day for wind and solar, and JMU is benefiting. Thank you so much for joining us on this tour. If you have questions or you'd like to schedule a tour yourself for you or your classroom, please feel free to contact us at case@jmu.edu.